Hello everyone and welcome to this new video where we're going to implement a Byte-Level BPE tokenizer on Python. So in the previous video we saw the theoretical or the intuition part. Today we will see the coding part. So what we will have as an input, we will have raw text, we will include an emoji and special characters, and then we will convert this text into UTF-8 bytes, which are integers from 0 to 255, and then we will train or apply the algorithm to find the most frequent pairs of the adjacent bytes and merge them into a new single token. And then for the output, we wish to get a compressed sequence of tokens and vocabulary of merge rules. So why byte level? Because in the standard BPE, which works on the Unicode characters, it can lead to massive vocabulary. For example, different languages have different characters, emojis, special characters, etc. So the byte level BPE breaks everything down to bytes first, ensuring the base vocabulary is always just 265 items, and then builds up from there. So let's start. We will define two core functions: the getStats. It counts the frequency of every adjacent pair of tokens in our list. So we will see later an example. The merge IDs function, we will replace all occurrences for a specific pair, P0, P1, with a new token ID. So here, for this first one, we have the IDs, which is the current list of integer tokens. They start as raw bytes, evolves into merge tokens. Again, see the previous video to understand what we're talking about here. Pair. It's a tuple of two integers we want to merge, for example h and u, or their byte equivalents, and then the idx, the new token ID we assign to this pair. So now we prepare, this is the algorithm of BPE. Now we prepare the training data. This is this has the critical step of encoding the UTF-8, which converts the string. We will give it this text with an emoji, as we said. So we have text, which is the string, and the tokens, which is the text encoded. So these are the original bytes and the initial length. Okay, so now this is the we will run the algorithm. We loop the merges times. In each iteration we find the most frequent pair and merge it into the token. So for the parameters, we initialize the vocabulary size to 270, which is the target vocabulary size. Since we start with 256 bytes, because from 0 to 255 we will perform 40 merges. So the merges is the dictionary storing the values we learn. So yeah, and the current token ID it starts at 256, as we said, and increments with every new merge. We can see like we performed 14 merges, and the final length was 5. So the compression ratio is 5x. So we can see that we did the job, or we like compressed the text. This 5 is this 25, the initial length, divided by 5. So we started by 25 and length, then we ended up with 5. So now we can see that our learned merges to tokenize new text. We also implemented the decode function to reconstruct the text from tokens. So if we give it like the encoded text, we can get it back the original text. This is just to verify that what we're doing is true. So we have two functions. The encode convert the input text into bytes, then we apply the learned merges in the exact order they were created, sorted by the IDs, and then we decode, recursively expand tokens back into their constituent pairs until we reach the original bytes, then decode using the UTF-8. So if we give it back, it encoded it and then decoded back to the correct word. So this is correct, as you can see. So that's it for this video. It's pretty simple and straightforward. So thank you for watching. Please like and subscribe to the channel.